Hello again. I'm returning back to a problem that I posted a few days ago here on YouTube. It's the 3 times 3 minus 3 divided by 3 plus 3. A lot of people have gotten the correct answer on this one, but a lot of people answered 5, and wanted to cover a little bit more about it. I'm going to link to that other video. We're going into a little bit more detail, but just to review the problem again, remember the order of operations. Multiplication and division have precedence over addition and subtraction. You need to solve the multiplication and division first. Multiplication and division are solved left to right because they have equal precedence. So, as you can see here, 3 times 3 is 9. We bring that down. 3 divided by 3 is 1. So this 3 times 3 minus 3 divided by 3 simply becomes 9 minus 1. And then we're just left with a plus 3 over here on the end. 9 minus 1 plus 3 equals 11. Pretty simple. Um, However, the people that are getting 5 are just solving left to right. And there's a number of reasons for that. People forgot the order of operations that they've been taught, and they will just simply solve left to right. And what they're doing when they're getting 5 is they're multiplying 3 times 3, getting 9. But then they're taking 9 minus 3 and getting 6. So they're ignoring the fact that the division needs to be solved next. And they're just going ahead, they're doing 9 minus 3, getting 6. Then they're left with 6 divided by 3 plus 3. They're taking 6 divided by 3 and getting 2. 2 plus 3 is 5. And again, that's incorrect. A lot of people are solving it left or right because there's this myth out there that a lot of people, they sort of remember the order of operations. They might remember hearing acronyms like PEMDAS or BODMAS. And of course, the P is parentheses, the B is brackets. And for some reason, a lot of people think that, well, you have to have all of those things, otherwise you ignore all of them. If you're missing one of those items, you ignore everything. And that's just not true. But you see posts like this one all the time. I did block out the names, but I've got an individual here who, and this is an older gentleman that posted this, but he said it was 5. And he said, well, there's no brackets. So he did exactly what I explained. 3 times 3 is 9. 9 minus 3 is 6. 6 divided by 3 is 2. 2 plus 3 is 5. And then his reasoning for that is, well, there were no brackets. It says 5 if you do it the old-fashioned way. 11 if you use my Android calculator. So this is the other thing too. A lot of people are like, well, I'm convinced in my mind that the old way was 5, but since my Android calculator tells me it's 11, well, Android calculators weren't around when I was in school in the 50s or whenever, so it must be some kind of newfangled math. And that's really some bad thinking because the order of operations really dates all the way back to the 16th century as far as Western civilization. And I'm sure it goes back even further than that if you look at other civilizations. I mean, look at the formula for the area of a circle, okay? A equals pi r squared. You solve r squared before you multiply by pi. Well, why is that? Because if orders or exponents have priority over multiplication, that's a pretty old formula. I'm guessing the formula for the area of a circle has been around probably longer than anybody here has been alive, but that's just me. There's nothing old-fashioned about ignoring the order of operations. No textbooks were ever written uh, that taught blindly to solve left to right. I can pull up any textbook that covers this topic. Performing a series of operations indicated in a numerical phrase, you always perform the operations of multiplication and division before the operations of addition and subtraction. And of course, we're not looking at exponents in this case. We're not looking at anything inside of parentheses in this case. When you have something like 3 times 5 plus 2 times 7, guess what? You solve the 3 times 5 and you get 15. The 2 times 7 is 14. You add them together and you get 29. These are not new concepts. This is not new math. A lot of people, unfortunately, have just forgotten. Here's the mathematics textbook. This one, I see this one shown a lot as an example. There's a textbook, teacher's edition from the 1950s, order of operations. Okay? And it does say that parentheses and other symbols of inclusion are the customary means used to make clear the meaning of a numerical expression. However, mathematicians have agreed on a rule to fall back on if someone omits, that's the key word, omits punctuation marks. We're talking about parentheses or brackets. The rule gives the order to be followed in performing the operations indicated in the expression. The agreement implies, for example, that, and so they're going through the different examples like 5 plus 3 times 2. Guess what? That is broken down to 5 plus 6 or 11. And why is that? Why is that? Here it is. It's explained right here. In a numerical expression containing a series of numerals connected by symbols of operation, you agree to follow this order. You simplify the expression within each symbol of an inclusion. And when they talk about symbol of inclusion, they're talking about parentheses or brackets. Now, if you don't have those, number 2, perform the multiplication and division in order from left to right. Finally, do the addition and subtractions in order from left to right. So there you go. This is from the 1950s. It goes back beyond that too. Um, so just wanted to reiterate that. Been trying to stamp out that mythology, but boy, there's a lot of people who really think that if you don't have parentheses or brackets, you just ignore them. And I want to stress that is not true. Hope that's been helpful. Catch you later.